Welcome to this video of what is scientific notation. Now, scientific notation in general is a way to write either really big or really small numbers. And when I say really big, I don't mean like 10,000. I mean like 10 billion. Or really small, like 10 millionths. Like something really big or really small. And so we write that as a number times 10 to some power. And we're going to get more into writing it and actually using it in later videos. For this first one, we're just really kind of getting into what it is and dealing with some of these really big numbers and really understanding numbers. Maybe that's a better topic for this video, is understanding numbers. So first we have this table, and this table has three columns. We've got the American name for numbers, the standard number. See, when we say standard number, we mean numbers like we're used to seeing them written out. And then the last one, you see this as a power of 10. You will notice that the middle column is all ones with zeros, right? We don't have anything else, nothing tricky. That way we have some continuity between these columns. So if I have 1 as a name, the standard number is a 1, the power of 10 is 10 to the 0. The American name of 10, which is a number 10, which is 10 to the first power. So when you're looking, and I want you to hit pause and complete this table, but you're going to see a pattern. So go ahead, hit pause, finish this table, come back and check your work. Okay, so hopefully you see in the American name pattern, you go 1, 10, 100, right? 1,000, 10,000, 100,000, 1 million, 10 million, 100 million. It's a pattern. When you look in the standard number column, as you move down, each time you're simply adding on another 0. So as you move each section, you're adding on a 0. And then in the power of 10 column, your exponents are going up by 1. And we're going to come back and look at this table here in a bit. Hopefully your handwriting may be a little bit better than mine. But when we go to this page, in general, there's a new name for every how many powers of 10. We call these periods. Okay, so when you're looking at them, there are 3 thousandths, then there are 3 millions, 3 billion, 3 trillion, 3 quadrillion. So for every third or every 3 powers of 10, you change names. Now in the second question, what's the relationship between the second and third column? Well, so we're looking at these two columns here. If you look at the exponent of 1, there's 1 0. Exponent of 2, 2 zeros. Exponent of 3, 3 zeros. So our exponents are going to kind of help us hold place value as we get into scientific notation. Okay, so the exponent equals the number of zeros when you're comparing those two columns. All right, let's get to some more, maybe a little bit more fun problems here. Which of the following is the correct way to say this number? Could it be 1,200? Could it be 1,200? Or both acceptable? Well, in this case, both are acceptable. And it doesn't matter, right? It might depend on where you're at, like what part of the country you're from, of where the way more people speak. But mathematically, they are both acceptable. Number 4. Why might the British call 1 billion 1,000 million? Well, I'm going to show this mathematically. So first thing, a billion. If you recall, billion means 9, right? There are 9 zeros if we're talking about a billion. So a billion is this number right here in blue. And I'll color code to kind of help. Now, when I go to 1,000 million, well, first let's talk about 1,000. This is 1,000 right here in red. And then if I add to that, let's go green, million means 6. So if I had 6 zeros to the end of that, because million means 6, you will notice that my two numbers are equal. So 1,000 million might sound silly, but it's the same as 1 billion. How many billions are in a trillion? Okay, so we're going to start with a trillion, and if you recall, trillion means 12. So that's a 1 with 12 zeros. Okay, now billion means 9. So change color for effect. Billion means 9. So if I take out 1 billion, this is 1 billion, how much is left? 3 zeros, and 3 means 1,000. So there are 1,000 billion in a trillion. Because when you took out the billion, you still had 1,000 left from the trillion. Excuse me. Number 6 is going to be similar to that. How many thousands are there in a million? Well, a million means 6. So if I just write my 1 million, then I say, okay, 1,000. 1,000 means 3. So if I take out 1,000, what's left? another 1,000. So there is 1,000 thousands in a million. So I think it kind of helps to visualize, maybe use different colors and kind of take things out. You can, be the judge of all that if this makes any sense. This is just kind of understanding how big numbers kind of relate to each other. And then number 8 is kind of fun. And we're going to get more into this later when we get to conversions in Unit 2. But when we're counting to 1 million, how long would it take you to count to 1 million if it takes you 1 second to count each number? Well, to me, that's a quick, easy answer. 1 million seconds. Right? 1 second per number. Easy. But can you really grasp how long a million seconds is? And you're probably thinking, well, it's not very long because seconds go really quickly. True statement. But how much is really 1 million seconds? So let's look at this. 1 million, we're going to do some math here. Million means 6. So this is 1 million seconds. I know that there are 60 seconds in 1 minute. So if I divide 1 million by 60, that will tell me how many minutes I have. So this leaves me with 16,666.67 minutes. I still can't comprehend how many minutes that is. So I'm going to say, okay, I now have 16,666.67 minutes. Well, I can change minutes to hours because there are 60 minutes in each hour. Now, when I do that, the minutes cancel out. I'm left with hours. So I'm going to take my minutes, my 16,666.67, and I'm going to divide by 60. And that leaves me with 277.78 hours. Or I still can't really grasp that. I mean, 277 hours, it sounds like a long time. But let's continue this. 277.78 hours. Well, I know there are 24 hours in 1 day. Notice how I'm just going one piece at a time of what do I know. That makes my hours cancel out. So if I take 277.78 and divide by 24, I'm left with 11.57 days. Meaning, if you want to count to 1 million, where it only takes you 1 second per number, it's going to take you roughly 11 and a half days. That is nonstop counting. You can't breathe, you can't talk, you have to count. And if you think about it, you're going to have to say like 6,732 in 1 second, and it just took me 3 seconds to say that. So this is a really generous estimate on 11 and a half days to count to 1 million. I just think that problem's kind of fun. I don't know why you would ever need to know that, but worthless use information is the key to winning Jeopardy, so you're welcome. Thanks.